We tend to use the words fear and anxiety interchangeably. They feel similar, but to the nervous system, they are two entirely distinct biological responses. Both of these emotions rely on a single shared processing center, the amygdala. Think of it as the master threat calibration system for human survival. This diagram of a brain cross-section shows what happens when you encounter a direct physical threat, like a vicious dog. A red alert signal shoots from the outside world into the lower, primitive part of the brain called the subcortex, immediately activating the amygdala. That direct hit is fear. Anxiety operates differently. Notice how the external threat fades away. Now, a new, pulsing yellow signal begins in the cortex, the higher-level thinking area of the brain. This is where we construct scenarios, like wondering what might happen if we wander into an unfamiliar forest after dark. That mental script travels down to activate the amygdala. For these emotions to be helpful, one condition has to be met. The alarm level set by the amygdala must be appropriate to the reality of the situation. Human survival depends on this delicate internal dial. But in practice, the dial is frequently out of sync, producing extreme responses that dictate how we behave in the real world. If we slide the threat spectrum to the left, we find severe underactivity. In this state, the amygdala fails to register danger at a normal level. This underreaction is a defining characteristic of psychopathic personalities. Many criminals take massive risks because they are aware of the possibility of getting caught, but their brains biologically fail to generate the sense of threat required to deter them. Yet, a less sensitive amygdala is not always a drawback. Top-tier surgeons and fearless firefighters often have naturally dormant threat responses, allowing them to remain steady in high-pressure environments where an average person would be overwhelmed. You don't have to be a specialist to experience a naturally muted threat response. Almost everyone goes through this stage during their teens and early 20s. An adolescent's frontal cortex, the area that plans rational responses and processes anxiety, has not yet reached full maturity. Because of this, it fails to activate the amygdala with the same intensity seen in a balanced adult. The result of that missing anxiety signal is a brain that can be carried away by excitement without thinking twice about the outcome. The writer knows a crash is possible, but the prospect doesn't trigger the internal alarm needed to make them slow down. While this lack of fear can be destructive, it was also a necessity as humans evolved. Millions of years ago, it was the fearless youngsters who persuaded their worried parents to abandon depleted hunting grounds. This adolescent stage provided the psychological momentum to set off into the unknown. Without this biological window of fearlessness, early humans likely wouldn't have attempted the massive migrations from Africa into Asia and Europe. When we move the slider to the opposite extreme, we see the results of severe amygdala overactivity. The most extreme manifestation of this is a panic attack. It is a state where a person feels intense horror and a certainty that they are about to die, even when no physical threat is present. Even good news can trigger this if the higher-order regions of the brain begin to overthink it. A student getting into medical school might start looping through concerns about the coursework or the shame of dropping out. These thoughts multiply, feeding into the amygdala until the system is violently vibrating. The amygdala mistakenly judges these internal thoughts as indicators of a complete disaster. It sounds a forceful alarm, triggering massive physical responses: perspiration, a rapid pulse, and shortness of breath. Firing on all cylinders consumes a massive amount of energy. To prevent total exhaustion that would impair survival, the brain uses a physiological safeguard to shut down the attack after only a few minutes. A panic attack isn't a sign of mental weakness. It is a survival system that has incorrectly identified a mountain of thoughts as a life-threatening emergency. When we look at the center of the spectrum, we find level of calibration is usually found in people with high emotional intelligence. They have a developed ability to manage their internal responses, ensuring the amygdala's alarm stays in sync with the actual level of danger. Understanding these mechanics provides a new way to view human behavior. A teenager's recklessness or a sudden wave of anxiety aren't just personality traits. They are the mechanical outputs of a specialized processor. When the brain misinterprets the world,
We aren't broken. We are simply navigating modern life with an ancient survival dial that is constantly struggling to find the right setting.